Good afternoon. Thank you for coming here, being interested in what we do and what we want to show you. So we are a small company, but we believe we do great things. My name is Tiberiu Baramboy. I'm one of the founders of Expertware, and we are here to show you, together with my colleague Ali, really a live multi-step attack and how that attack would have been prevented or detected much earlier in its inception, and of course blocked or mitigated by the good SOC team. We'll show you both sides, the attack and the defense. The attack, you will see the description, but really it starts with the phishing emails. It will drop a document, a Word document, and based on the embedded macro with PowerShell or something else obfuscated, can get persistence on the system, can download the dropper, disable the UAC, do process following, and much more. And ultimately, via the discovery vulnerabilities in a lab network, we'll detect the WordPress, we'll get the passwords from there, we'll do a password spray attack, and we'll, with the ultimate aim of getting domain admin credentials. You will see that. Ali will show you that how it does, quite technical really, with code behind. But before that, let's see on the defensive side how we can prevent such attacks. And what you see here is we got a European grant for innovation in cybersecurity, and we are proud that we got the highest score and the highest budget a couple of years ago. And what you will see today, or at least in the second half of the presentation, will be really how you can defend. The project is just to point a few things out to get the pointer. So we have really software or separated software as a service tenants. Each tenant for each customer with its own encryption key. Ultimately, there we have a SIEM. It's based on OpenSearch, which is an open source data lake. So like Elastic, but free of charge, free of license. Each customer has those components, and they will share certain components, CTI components, vulnerability scanning, threat hunting, detection rules, which of course makes sense to be shared, because once developed or once enriched, they can feed all the potential tenants, all the potential beneficiaries of the solution. Last but not least, we get out of the beneficiaries who want to do that, and they give us the agreement, we get specific security events. We anonymize that, and the anonymization has been checked by the equivalent of BCC in Romania, the NSC, which is our partner in the project. We anonymize them, and we build really a cybersecurity research data lake, where of course, ultimately we will put some machine learning. Now, in a nutshell, what it does, the SIEMBIOT, SOC as a service, there were 30 connectors, but now probably there are 35 connectors. Continuously and updated cyber threat intelligence, and we have over 15 plus billions of events. We ingest between 15 and 20,000 a day, and we enrich them. What means? We mean that out of those CTIs, we curate them, and the ones which we consider that they are relevant for your tenants, for your SIEM tenants, we push them to the SIEM tenants and automatically launch a detection rule. The security, the integrated incident module, so if you also take our services, then we will follow the incident, and we will do in such a way that you won't get victim of a complex attack like the one which my colleague will show you. The attack overview, I will pass it to Ali because he's from the offensive team.
Yes. Hello everyone, thanks for being here. It's great to see so many of you. It really gives us the motivation to be doing this. I'll be going through the attack overview right now. So I have a small sequence diagram. Before you can you hear about it, you should understand the thing a bit more. The first thing that we're going to be doing, we're going to be sending a malicious macro. So we're going to have a Word document. We can pretty much say it's a CV or a resume or something that has a malicious macro embedded in it. That malicious macro is going to download the dropper. That's going to give us initial access. What the dropper is going to be doing, that's going to be performing a process on the victim's computer. and that's how we're going to get access to the host. Then we're going to perform a UAC bypass, and we're going to get a higher integrity token on the machine. And then we're going to be performing some internal scanning, exfiltrate some data, and then based on those internal scanning, we're going to be finding a vulnerable internal website that we can have or perform a man-in-the-middle attack in order for us to get the administrator credentials. Now, once we got the administrator credentials, we can log into the domain controller as domain admins, and yeah, the job is kind of finished there. We can create our own accounts and so on. Now, let's talk a bit about how attackers usually gain initial access to the host, to the victims. Well, 91 of the cyber attacks as a whole, they start with phishing email, and we can further divide these into two. And we're going to have 70% of the phishing attacks aiming to steal credentials, but 94% of them aiming to manipulate money. Now, let's go through each of these stages. The first thing that we're going to be doing, as I said, we're going to be sending a malicious macro. Once this Word document is going to be open, it's going to execute a PowerShell command that's going to download the dropper from our server. You can also see that we store it in Windows tasks as c.exe. There's no apparent reason. It's pretty much writable by anyone, and users don't usually check the tasks folder, so it's going to pass by kind of undetected. Now, if you want to hear more about the dropper is going to create a suspended process, and then it's going to create a section. A section is just a piece of memory that may be shared by multiple processes. And then we're going to write our shellcode to that section. We're going to modify the instruction pointer of the suspended process to the section where we've injected our shellcode, and then we're going to resume our process. And so once the process is resumed, we have initial access. Now let's see the development of the dropper. For the development of the dropper, we've used Metasploit shellcode, and so we've had to encrypt it quite a bit because there's been lots of research on this Metasploit. And as you can see here, the first thing that we're going to be doing, we're going to be performing a SOR encryption with some proprietary keys, and also we're going to be scrambling up the data, and what that means is that we're going to be adding a byte between each byte of the shellcode. And so in this way, we make sure that we kind of break down all the signatures that Metasploit has. And then, of course, then we start reversing some bytes and so on. Now, if we go further, you're going to see that we're going to first create a section using anti-create section, then map it, and then hook our shellcode to that section. And as you can see here, this is the section that we've had on the initial creation, and after we've copied our shellcode to that section. Now, as you can see, we're going to be having notepad.exe as the suspended process that we're going to be spawning on the victim computer. Then we're going to map the notepad.exe to the section we created. And then we're going to be using a queue so that the first thing that's going to be executed once we resume notepad.exe, it's going to be our shellcode. Now we're going to also migrate it. So before migration, it's going to be just like a child process, notepad.exe, under dropper. But then once we migrate it, we're going to be completely executing stuff from another process. Now, once we're in, we can try to do some other stuff. The thing is that this is not something that's going to bypass any security measures like EDRs. It's going to be detected most of the time because we're talking about Metasploit shellcode. So it's also not that, from an ethical point of view, it's not that good to be showing bypassing the EDR and so on. But what we thought of is to perform some UAC bypasses and then start some internal scanning further on. If we check the current session, we're going to see that we have a medium mandatory session, medium mandatory level, which just means that we're standard users in the system, and we want to get that higher level of sessions. And for this one, we've used a simple loader that's just going to load it on the victim's host. And also we've used HAPC2 that we've encrypted using AES encryption. And as you can see those libraries there, in the next line you're going to see in the IAT table that all the functions that we've used will be shown there. But that's not an issue because if we talk about Microsoft Defender, that's not going to detect them because there's multiple processes that use those functions as well. And so, yeah. Now, once we've performed the UAC bypass, we've done it using computer defaults, and if you ask yourselves why, it's because computer defaults, once executed, we can go through, it's going to go through the registries, and it's going to execute whatever command we gave it to execute. And so, when it's going to execute it as administrator, so that's going to give us a higher session. Now, computer defaults is a link of the non-binary that you can also check it on the website of the project. Now, once we've performed the UAC bypass, you can see that we have a high mandatory level here as a session. Then, if we go further, you can see that we can now exfiltrate, for example, the summon system files using an SMB shell. But we can also go ahead and perform some internal scanning. Once we perform this internal scanning, we find some interesting stuff, such as a domain and something that's running on port 80 and port 443. If we go further, you're going to see that on that website, or on the ports that were on port 80 and 443, we have a WordPress site that's also vulnerable to remote file inclusion. And we can see that by the warning that we get here. Once we scan the plugins of that WordPress site, we're going to see that we have required ones. Usually when we see required ones as a warning, we're going to see that there is some file inclusion vulnerability on that website. Now, if we go further, we're going to see that we can include our own login page and wait for administrator credentials right here. Once some user or some administrators enters the credentials, then we're going to get that on the website. And then we can, based on that, we can perform a password straying attack because we go on the premises that most users they use their passwords on some other systems as well. And so we're just going to use the same password with different usernames, and that's going to give us access to the domain controller. And I don't know if you remember, the port was open on the domain controller, and so we can log in as well using Remina and create a new account and so on. But basically, once we're on the domain controller as the main admins, the job is kind of done. Now I'm going to give the link to can you show them the SIEMBIOT? Yeah, before that I'm going to show you the difference, what we see as alerts.
If we talk about SIEMBIOT,
Now let me show you how we could have detected and stopped of this from even the first level. If we go to Syembiot, you're going to see that we have some alerts. These are the most it's part of the post-intrusion detection system component that we have in Syembiot. And we have the first alert being a potentially suspicious file dropped in a local folder. So from here we can already see that there is something, a PowerShell command that was executed and downloaded a dropper, some kind of file, we don't know yet, that was stored as c.exe. And if we go further down, we're going to see that it was from winword.exe. So that was the Word document. If we go further up, you're going to see that custom command prompt executable was dropped in Windows Phone. Those that know, when we use, for example, computer defaults.exe, we're going to have to copy the command prompt and rename it as something else. So in order not to trigger, for example, Microsoft framework. But yeah, that's one of the steps. Then we're going to see a suspicious registry modification using reg.exe, and we can already see that there is a loader here that's being registered using attack.exe. We can go further up and see an abnormal process generated by Windows tasks c.exe. So the dropper that was downloaded from the Word document was stored here in Windows tasks as c.exe and then executed afterwards. Then you're going to also see living on the land while the execution of reg.exe. So that's when the command was added, so reg-add was used in order to add the command to be executed from computer defaults. We also see the salvage system files being shared with an external device. And we also have the directory of the web server here, where we've included our VP login.php files. We have a really high granularity that allows us to see every single step of the attack over here. We also see the log account created by the administrator account, because we've got the administrator account credentials. But what I want to show you is also the network. We have a network intrusion detection system that's going to, I think, one of the most nicest modules that we have here, or the component that we have, is the fact that we book the packets even before they reach the internal network that we have, before they reach the host devices. Then it hooks them, assembles them, and then checks them against various rules. And as you can see here, although we've encrypted and obfuscated the payload that we have from Metasploit, it was still detected. You can also see various alerts as executables being downloaded, or etinfo.net quad host the alert request. That's because we downloaded our loader from a single server that didn't have, for example, a domain name. So it was just an IP address that we posted. We also see shell activity over SMB, so we can also see the exfiltration over the SMB shell. And if we look further down, we're going to see that we have various alerts from the scanning, from the internal scanning that we performed. And we also have RDP response to external host and brute force detected over RDP, because we've performed the brute force over the 339 port. And so on. So we have a really high granularity in both the network intrusion detection system and host intrusion detection system that allow us to see every single step of the attack. And those can be stopped even before they reach the network that we have. I'm going to give the link to my colleague now.
I will take over. So, in a nutshell, we showed you how we attack, but we showed you how, after the first step, we had all those alerts. All those alerts would have been stopped by the SOC team. And all those alerts are in our data lake, and they are both from the hits, from the host, and from the network traffic analyzer. You saw that there are duplicated alerts, some from the hits, some from the network traffic analyzer, all in one place. So a SOC team would have stopped this after the first or second second step of the attack. And that's the power of, I would say, our platform, our open SIEMBIOT. Now, what we show you here is, in fact, a few other functionalities. We still have 4 minutes. The platform, by the way, it's a live platform. What you see here, it's not a PowerShell, PowerPoint, so it's really a live platform, and that's our own tenant, which monitors Expertware. What we wanted to point out is, besides all the vulnerabilities, which we have a multi-agent vulnerability scanner, meaning that if we take from an EDR, but we take also from the networks. And as you see, all the detections which are all the vulnerabilities detected, we update them daily from the GISA, from the NVD, and in the future from the European Vulnerability Database. So if a new vulnerability appears today, we do have it in the platform, and based on all the packages which we know that we have on our systems, we will mark the vulnerability. We do not have to do scans and imports. They will be in the same platform where the SOC team will act, and hopefully the operation team acts more. But everywhere we put it's our own model, the AI model, where you see the SI, SIEMBIOT intelligence. In fact, it's a machine learning model. Everywhere you see this icon, you can question it, and it will give you information from our own model, which is in our data center, so it is not public. We do not take any data of your data and put it somewhere else. It's in your tenant. And there, everywhere you can see about this vulnerability or about how you can harden your platform. For example, the observable, they are coming from threats, they are coming from live CTIs. As I said, we have 15,000 every day. They are coming into the platform. You have them already integrated. You do not have another platform. It's here, and it's yours. The observables will give you, for example, I have a new observable which appeared today. Again, I can ask my SI agent what is about this, and it tells me what this observable means. So it's a real helper for both the defense team equally, but for operational team. Last but not least, you will see also, because one of the questions some of our customers put is, what I am protected, which are the automatic rules which are running against my data lake to detect proactively some potential attacks or vulnerabilities. And to this question, we have this mapping of the automatic detection rules against the MITRE attack framework. And as you can see, for each of them, I have 64 rules. I can expand it. It tells you which rules are enabled, which rules are not enabled in my environment. So enable means that if a match of the query against your data lake, of the CM data lake, is found, it will generate an alert, which of course the SOC team has to deal with. And out of the alerts, they can make cases, they can make incidents, and hopefully stop the attacker early in their way, in their journey. It's not just the attackers of the CM or the automatic detection rules. We evaluate also continuously your posture, how well is configured your machine or your devices. We do the GIS, the Computer Internet Security baseline. We apply it and we evaluate all your machines, and it will show you. Of course, I have the SIEMBIOT intelligence. It can tell me what this control of GIS means. It means what specific registry or configuration item I need, and everywhere you can question it, will give you the explanation in one place. You don't have to go and Google it or use ChatGPT. For the checks, it will show you, which are the checks and which are the checks enabled and which are the checks not enabled. If they are failed, that means that it's something I can still further harden my machines, improve my security posture, so I'm less prone to get attacked and get compromised. Yeah. Now, if you look at few other things which I would say they are of interest, so it will be the NIST tracker. So I want to see out of my rules which NIST 2 audit controls I have, and you have the list of all the NIST 2, and equally it shows you which controls, which related controls are, and which events are mapped to that, so they are audited, so you can prove to an auditor that yes, I have these controls in place, and they are monitored, and if they will be breached, an alert will be generated, and the SOC team will handle it. So These are just few of the items we want, but as you can see, all these things, the customer health and the executive, we don't have just the premise data center, we have the premise and the Azure events everywhere where you see the DQL query. Out of a click, I can create a query from an observable or from an event. For example, I have some colleagues here. You see, I have this little OK. If I click on it, it will automatically filter and put a query, in fact, just for what that user did. And as you can see, it created my DQL query, but I have as well a set of DQL queries which are predefined by us, and you can contribute to them. So it's a platform, it's an open platform which we continue to improve, and it came from the shortcomings that there were too many disparate tools, and the integration was not efficient, and that's what we try to solve here. I believe that we are running out of time. I would love to show you more, but please come to our booth, and it's come to our booth and we'll show you a demo. Yeah, a full demo. If you have questions, so we'll be glad to answer any questions you have.